Today we're going to talk about injector testing with a snap-on low amps clamp and the differences between voltage testing and current draw testing. Trevor, talk to us about injector testing.
Yeah, hi Brian. Whenever I'm doing any scope work and I'm testing actuators, I always use this wonderful tool, the low amps clamp. So today we're going to do some injector testing on this, first of all using voltage, and then we'll introduce the low amps clamp to see what extra information it gives us. So to start off, we're going to look at voltage on the injector on this vehicle. The settings we've put into our scope for our injector is we're looking at a test probe for voltage, 100 volts and a time scale of 20 milliseconds. Once I've got those settings in the machine, I'm just going to plug or back probe our injector signal wire. So as soon as we've got the injector signal wire in there, I'm just going to start the car and we'll have a look at what we get in voltage. Okay Brian, what we have here is a typical petrol injector trace. We can see battery voltage here. This is the injector off, and we've got the command from the ECU to turn the injector on. This is where it brings the battery voltage down to earth. It holds it at earth for the length of time it wants it to squirt fuel, and then it releases that earth when it wants to turn the injector off. At the point of release though, what we get is a back EMF spike of typically 80 or 90 volts caused by the collapse of the magnetic field. And also, if we can zoom in a little bit here Brian, we have a little bump where it returns back to battery voltage. This little bump is where the needle actually hits the seat. This is the point the actual injector turned off. So the command to turn off was here. The injector actually stopped squirting fuel here. So what we're actually looking at here is just half the story.
So does that confirm if an injector is functioning correctly?
Not fully, no. To get the full picture we need to look at current. And whenever I'm looking at any actuators, I always look at voltage and current, and I'll demonstrate for you now. You can get so much more information by looking at current as well. It's a very straightforward device, this. It's just got a trigger here. We can open up the clamps and we actually put the clamps around any wire. It's a totally intrusive device. I just plug the black lead into an earth on the back of the scope and put the red lead into any open channel. So we're going to use the green channel for this. Once we've put the leads in, we need to tell the scope that we've got this connected, so we'll do that right now. I'm going to turn on the green channel, or channel 2, and I've told it that we've got a 20 amp clamp connected to it, and I've set the scale to 2 amps for a petrol injector. The time scale we have at 20 milliseconds, that is the scope setup, so we've done that. All we need to do now is on the front of the amps clamp we've got a slider switch with an off, 60 amp and 20 amp mode. I'm just going to put that into the 20 amp mode. To complete it, all we do is press the 0 button.
Do you have to use the 20 amp mode for all injectors?
For all petrol injectors definitely, and most diesel ones as well. It is the most common setting you're going to use.
Okay.
All I do now is put the jaws of the amps clamp around the power supply for the injector, not the signal wire.
So what does current actually tell us, Trevor?
Well, what we're actually looking at here now is we're looking at the internal workings of the injector. We can see when it actually opens, not only that, how much current is that winding actually drawing. So if we actually look at the green trace here, superimposed on the voltage trace, with the injector off with 12 volts there, we have 0 current flow. As soon as the ECU commands the injector on, we get a rise in current, and we can see this here as a current ramp. And we can see a little bit of an oddity here in the current ramp. It looks like a little seagull wing effect. That's a very good diagnostic indicator. This little seagull wing effect is where the current built up to the point where it overcame the spring pressure and the injector actually opened.
So that means the injector is consuming power.
Exactly that. And we can see from both traces that the command for the injector was in fact here, but it didn't actually open till here. The command for it to close was here, and in voltage there we can see our little bump where it actually closed. So by looking at current we can get a lot more diagnostic information about our injector. Let's look at some typical faults. A couple of common faults. One is a sticking injector. If I have a sticking injector, the current's going to have to build up a lot further before it opens. So by just doing a comparison between the injectors, I'm looking for this opening point to be in the same place on all four injectors.
And if one injector has the seagull curve in a different place, what does that mean?
Well, if it's higher up the curve, it would indicate maybe a sticking injector. If it's opening too early, maybe the spring's gone weak. But you cannot see this in voltage alone, so whenever I'm looking at any actuators on a motor car, the first tool I grab is my scope and my low amps clamp.
To look for the differences between the injectors, we're looking for the point of them opening, be it low for weak springs or be it high for sticking injectors.
Exactly, and also the overall current that the component is drawing.
Trevor, thank you.